Right, good afternoon or morning whenever you're watching this. This is Miss Valdez, and I am going to work through the 2.1 through 2.4 practice test. I'm going to go right in order, but if you need to fast forward to a different problem, that is okay. In this first problem, we're given this function, and in part A, we're asked to find f of -4. And all that means is everywhere you see x, you're going to plug in -4. So we have 2 times -4 squared minus -4 minus 9. First thing we're going to do is -4 squared, which is 16. So this is 2 times 16. Minus -4 means plus 4, and then we have that minus 9 at the end. So we end up with 32 plus 4, which is 36. And if we subtract the 9 at the end, 36 minus 9 gives us 27. So that means f of -4 is equal to 27. All right. Part B is pretty similar, but we're going to replace x with this entire thing, 2 minus 3a. So f of 2 minus 3a, again, everywhere you see x, you're going to replace it with 2 minus 3a. And always put that expression or variable or value in parentheses. It's just going to make your work a little bit easier. All right. So one thing you need to be careful with this problem is this 2 minus 3a squared is actually something you're going to have to FOIL. So we're going to do 2 minus 3a times itself 2 times, because that is what a power of 2 means. So if we FOIL this, 2 times 2 gives you 4. And we have minus 6a minus 6a, so that will be minus 12a. Negative 3a times negative 3a is positive 9a squared. So we still have this 2, but then in parentheses, when I FOILed out that expression, I just get 4 minus 12a plus 9a squared. And then I'm going to go ahead and distribute this negative right away. So I have minus 2 plus 3a, and then I still have that minus 9 at the end. All right, now we can distribute that 2, giving us 8 minus 24a plus 18a squared minus 2 plus 3a minus 9. Then our last step is going to be to combine like terms. I have 18a squared, which does not have anything I can combine with it. And then for my a's, I have negative 24a plus 3a. So that's negative 21a. So these are done. And then at the end, 8 minus 2 is 6. 6 minus 9 is negative 3. So that expression is our answer. All right, let's move on to number 2. So in this problem, we are given this piecewise function, and we are asked to find f of -3. So that means I have to check this back part of the equation. So I notice the x value that I'm using is less than -1. Yeah, -3 is definitely less than -1, which means I have to use this top equation. So I don't even need to worry about the bottom one. It doesn't work for the x value I'm using. So if we plug in 2/3 times that x value, -3, plus 1, well, 2/3 times -3, you can just do 2 times -3, which is -6, and divide it by 3 and then add 1. So that's -2 plus 1, which gives you an answer of -1. So that is the function's value at -3. All right, we have another domain problem here. So if we're asked to state the domain, everywhere you have roots, you want to make sure you're not square rooting anything negative, which means we're going to take what's inside and say it's greater than or equal to 0. So if we solve this, part of our domain is just going to be x is greater than or equal to -3. So that part is just going to make sure that we don't do any square rooting of a negative. Then we also want to make sure we don't divide by 0. So I'm going to take x minus 2, which is our denominator, and say that is not equal to 0. So solving that gives us another part of our domain. X cannot equal 2. So you have all x's greater than or equal to -3, but x can't equal -2. So your domains are just the x's that work inside of that function. Okay, number 4 is going to take some time. So I'm going to do this one in three parts, really. The first thing I'm going to do is, given this function f of x, I'm going to find what f of a plus h is. So f of a plus h just means that everywhere you see x, you're going to replace it with a plus h. So I have a plus h squared minus 3 times a plus h minus 6. And then just like in the first problem, remember a plus h squared, that means you're actually going to be FOILing a plus h. And then I'm going to distribute this -3 right away, so we have minus 3a minus 3h minus 6. So if we distribute or FOIL this first piece, we get a squared. Then you're going to have an AH plus an AH, so we'll just put plus 2AH right away. And then plus H times H is H squared, minus 3A minus 3H minus 6. And if we combine our like terms, we end up with A squared. Actually, you know what? There are no like terms, so never mind. That's what we get. Okay, so now I'm going to find f of a. And f of a just means that in your function, you're going to replace x with a. So this ends up being a squared minus 3a minus 6. Okay, so I'm going to put it all together. I'm going to take that first function I got, a squared plus 2ah plus h squared minus 3a minus 3h minus 6 minus, and here's where you always want to put f of a in parentheses, otherwise you're going to forget to distribute that negative. So it's a squared minus 3a minus 6. And that entire expression is all over h. So now at this point, we're just going to distribute this negative. So this is going to end up being a minus a squared plus 3a plus 6 right here. And now we can start combining like terms. So I notice I have an a squared minus an a squared. So those actually cancel. I don't see anything to match up with the 2ah. I'm just going to rewrite that. Then I have an h squared plus h squared. There's nothing I can combine that with. I have a minus 3a and a plus 3a, so those cancel. I don't see anything I can combine with this minus 3h, but then I have a minus 6 and a plus 6. So that's everything left in the top, and it's still all divided by h. Now, if you do this problem right, your constant should cancel, and the only thing you should be left with is pieces or terms with h in them. So if I take an h out of each piece, I'm left with 2a plus h minus 3. And then remember, this is all divided by h, so what happens is this h and this h cancel, and your answer that you're left with is 2a plus h minus 3. So that is the final answer for this problem. All right, the next problem is going to involve a graph. So we are given a graph for this function f of x. And if it says to find f of 5, all that means is you go over 1, 2, 3, 4, 5 to that x value. And then I notice at 5, my function's value is 4. So this answer is just 4. There's no work to show here. The domain are your x values. So the x value that this graph starts at is negative 1, 2, 3, 4, 5, 6. So it starts at negative 6. The x value that it stops at is 1, 2, 3, 4, 5, 6, 7. So the domain is just the x values that your function lives at. The range is similar, but range is then y values. So the lowest y value I can see is negative 2. The highest y value I can see is 1, 2, 3, 4, 5. So my range, that's the y values that my function lives on, is from negative 2 to 5. All right, and then the last part of this problem says, on what intervals is this function increasing? Well, it looks like it's going up from this point to this point. And when you're talking about an interval, you only care about the x values. Okay, we don't really care about the y values here. We just care about the x values where it's increasing. So this x value here is negative 1, so that's when it starts going up, starts increasing. And then it goes until this point, which has an x value of 4. So from negative 1 until 4, this function is increasing. All right, now we're going to just look at some graphs of some parent functions and then a piecewise function. So in these problems, if you're ever in doubt, just make a table of values. For cubed root functions, I'm going to pick numbers that I can easily cube root. And you can cube root negatives. So I'm going to start at negative 8 because I know the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So I can just plot those 5 points. So here's negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. And remember, a cubed root function should look like a sleepy snake. So if you remember that, that's going to help you realize whether or not you did it correctly. So your graph should look something like this. All right, and this next one, I have a reciprocal function. So again, when in doubt, make a table of values. I'm going to use negative 2, negative 1. I'm going to skip 0 because notice if I plug 0 in here, I'm going to get undefined. So I'm just going to do 1 and 2. So 1 divided by negative 2 is a negative half. If you plug in negative 1, you get negative 1. If you plug in 1, you get 1. And if you plug in 2, you get a half. So you should remember that these reciprocal functions are always going to have asymptotes. So one of the asymptotes is just going to be at y equals 0, and the other one is going to be at x equals 0. So that's really just the two axes. So if we plot these points, negative 2, negative a half is right here. Negative 1 is right here. And you should remember for odd reciprocal functions, you get these 2 branches. Here's my other 2 points, 1, 1, and 2, a half. So if you know the basic shape of these graphs, you should be able to get a pretty good idea of what your graph should look like. All right, so that is the function for 1 over x. Okay. And then 11 is actually very similar to the one right above number 9 because these are inverses of each other. For this one, you can cube any number and get a nice number. So I'm just going to pick those fave 5, negative 2, 0, 1, and 2. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So if I plot those points, it's actually going to look pretty similar to what we got up above in number 9, except for it's rotated. So these are the points in our table. So if you graph those, you should get that snake-shaped graph. So there's the graph of x cubed. All right, now our last graph on this page is a piecewise function. So I'm always, like, what I like to do is locate that on my graph. So I know that at -1, my first graph is going to stop, and then my second graph is going to start up. So I sometimes like to put a vertical line through that x value. So this is x equals -1 right here. All right, so I'm going to do this top function. And that function is just a line. It's linear, 2x plus 1. So try to move this back over here. All right, so if we graph that, we can make a table of values, but you want x values that are less than -1. So maybe let's start at -3, -2, and I'm still going to use -1, but I'm going to make sure that when I get to the end of this table, I have an open circle. So if I plug -1 into this function, I get -5. Or sorry, if I plug -3. So you get -3 times 2 is -6, and then plus 1 is -5. If you plug in -2, you're going to get a -3, and if you plug in -1, you're going to get a -1. So I'm going to start with -3, 1, 2, 3, comma, -5. That's right there. And then I'm going to do -2, -3, which is here. And then once I get to -1, I think I put that in the wrong spot. Let's try that again. -2, -3 is here. And then this last point, remember, is going to be an open circle because it's x less than -1. So once I get here, it's going to be open. And then this graph is just going to keep going back this way. So that's the top line. The bottom line only works for x values greater than or equal to -1. So for this table, I'm still going to start at -1. And then this tells me greater than or equal to that dot is going to be closed when I start it. So I can do -1, 0, 1, and 2. Those will all work in this function. So -2 times -1 is 2. 0 times -2 is 0. -2 times 1 is -2. And -2 times 2 is -4. So here's the point -1, 2. And that's going to start on a closed circle because I can include that value for this graph. And then 0, 0, 1, -2, and 2, -4. And then this graph is going to keep going down and to the right because these are all the x values greater than -1. All right, so that is our piecewise graph. All right, moving on, we're going to look at transformations. So you are given the indicated transformations are applied to f of x. Write the equation for the final transformed graph. So for 13, I'm just going to say y equals for our new transformed graph. If you shift left 2 steps, that's going to look like this f of x plus 2. So that would be the final transformation. So remember, if it's left, that's horizontal. So this is opposite of what it looks like. So that's where it's showing up in parentheses as x plus 2. All right. 14 says stretch vertically by a factor of 3 and shift upward 8. So both of these transformations are vertical. I don't know why it keeps doing that. All right, I am just going to go back to that. So having some technical difficulties here, but hopefully you got that last part. So we were just on number 14. And I was saying that this is a vertical transformation and upward is also vertical. So both of these things are going to be outside of the parentheses. So I'm going to say y equals, and then a vertical stretch by a factor of 3 is going to be 3 times the original function f of x. And then upward 8 just means at the end you're going to add 8. Okay, So that is the two transformations that are being done here. Okay, and then in 15, we have a couple things going on. The first thing is we're going to shrink horizontally by a factor of 2. Okay, so that is going to be in the parentheses, and it's going to actually look like a 2x. So you would think a shrink would be a half, but it actually ends up being a number bigger than 1 when you were doing horizontal shrinks. And a reflection over the x-axis, that's just going to throw a negative in front of your function. So I'm going to say y equals negative for the reflection, f of x, and I missed a part here. Remember, we got to have that 2 in front of the x to do the horizontal shrink. So then this here would be your final function. All right, so we're going to use these ideas on some graphs here. So in 16, you have to figure out what's going to happen to this function that's graphed and then graph the transformation. So if it's in parentheses, remember it's doing left-right horizontal motions. And this -2 is actually going to make all of our points go right 2. So I only do like the corner points. So this first point, right 2, would be here. This point moved right 2 is going to end up on the y-axis. This point right 2 is going to end up here. And this point right 2 is going to end up here. So then you just connect those to get your graph. And that is it. All right, and the second one, if you have a number in front, this is actually going to shrink vertically by half. Right, so this point right here is currently at a height of 3. If I shrink that to half, it's going to be at 1.5. This one has a height of -1, so if I cut that in half, it'll be at -0.5. And then these other 2 points, kind of the same idea. Now notice that I did not change the x values. It's still starting and stopping at the same x values, but its height is half of what it was before. All right. In number 18, we have a horizontal shrink by a factor of 2. So all of my x values are going to get cut in half. The height of this graph is still going to be the same. So this first point currently is at -4. If I cut that in half, it's going to be at -2. This second point of interest is at -2, so it's going to shrink in half and be at -1. And then same idea over on the right. This is going to shrink in half. And my last point is going to shrink in half and be at 2. So notice it's still going from -1 up to 3 for the y values, but the x values got cut in half. So this is our new graph right here. All right, and then 19 is just a reflection, and it's actually going to reflect over the x-axis. All right, so this is our x-axis right here. This point is 3 above. It's going to reflect and be 3 below. This point is 1 below. It's going to reflect and be 1 above. And then the same idea over on the right side. So these are my final 4 points. If you connect them, then this is your new function. All right, now we're going to do some transformations that have a couple things happening. 20 is not too bad. This +2 is just going to make your points go left 2, and this -3 is going to make them move down 3. So since these are both just shifts, we can do that at the same time. If I walk this point left 2 and then down 3, it's going to end up right here. This point left 2 and then down 3 will end up here. This point left 2 and down 3 is going to end up on the y-axis. And then this point, left 2 and down 3 is here. And then again, just connect those to get your final graph. All right, and then 21 is probably the most challenging one just because we have actually 3 things happening here. We're going to reflect over the x-axis. So that's the negative. Then we're going to vertically stretch by a factor of 2, so it's going to be twice as tall. All right, and then lastly, we're going to move all the points up 1. Okay, so I'm actually going to do the reflection first, but I'm not going to connect the dots. So I'll do this first thing in yellow. So if I reflect over the x-axis, we actually did that in a previous problem, and we got these 4 points. And I'm not going to connect these because that's not really my final graph. All right, then I'm going to do the vertical stretch. So all of these are going to double in height. So this will be the point on the far left, this is the next point, and then the point on the far right. And then lastly, I'm going to move those up 1. So up 1 here would be my first point, my second point, my third point, and my fourth point. So notice that before my shape had a height of 8, or sorry, a height of 4. So you should be able to count this and see that this is now has a height of 8. And hopefully you can see that it is moved up a little bit and reflected. All right. So in 22 and 23, we're going to test whether the function is even or odd. So remember to do this. You replace the x's with negative x. So if we replace these x's with negative x's, we end up with negative x to the 4th minus negative x. And if you raise any function to a power of 4, it always ends up being even. So this just turns back into x to the power of 4. Minus negative x is actually a plus x. So if this was going to be even, both of these terms would have to stay as a positive x to the 4th and a minus x. That didn't happen. So it's not even. All right. If it was odd, both of these would change to opposite. So this would become a negative x to the 4th and a positive x. That didn't happen, so it's not odd. So this is neither because this stayed the same, but this changed. So you have to either have every term stay the same for it to be even, or if you have to have every term change to its opposite and for it to be odd. So since one of them changed and the other didn't, this is neither. All right, in 23, we have f of negative x equals negative x cubed plus 2 times negative x minus 7. And if you cube a negative, you end up with a negative. So this is negative x cubed. 2 times negative x would be minus 2x, but then this minus 7 stays the same. So again, I mean, this one changed to its opposite. This one, the second term changed to its opposite, but this one stayed the same. So since one of them stayed the same, but 2 of them changed, again, this one is a neither. And if you want to see what an odd or an even look like, I would recommend looking in your notes for 2.4 day 2 or looking on the 2.4 day 2 worksheet, because there were some that did end up being even and odd. So look at those for an example. All right, and then our very last problem has to do with the average rate of change. Okay, so remember, average rate of change is really just like the slope between the 2 points. So it's like, it's really very similar to the slope formula. So if you recall that formula, it's just f of a minus f of b over a minus b. And a and b are just the two x values that they give you. So in this specific problem, -3 is our a and 3 is our b. So the first thing that we need to find is f of -3. So if I plug -3 into this function, we'll just see what that ends up equaling. So I end up with 3 times 9 is 27 minus 18 plus 1. So 27 minus 18 is 9, 9 plus 1 is 10. All right, and then f of 3, we'll just plug 3 in for x and see what that gives us. So we end up with 27 for that first term again, but then it's plus 18 plus 1. So let's see that it would be 28 plus 18, which is 36, 46. All right, so now I'm going to plug those values into this average rate of change formula. So I end up with my f of a was 10 minus my f of b, which was 46. And then my a value was just -3 and b was just 3. So if we simplify that, we get -36 divided by -6, which gives you an average rate of change of 6. All right, so again, if you have any questions on that, feel free to let me know in class. Hopefully that helped you, and good luck on your test.